Hi, everyone. This is Kevin Kline speaking. With SQL Century, I serve as the Director of Engineering Services at SQL Century. Been here for exactly 1 year now, so that's kind of exciting for me. With me today is my good friend and fellow Microsoft MVP, Aaron Bertrand. Hi, Aaron.
Good morning, Kevin. How are you?
I'm doing okay. Now, how long have you been with SQL Century?
I started in October of 2010.
All right, so 2.5, 3 years now.
Hmm.
Yeah, boy, it has gone fast. It has gone really fast,
Yes, it does move very quickly.
but it's been good. Folks, so much for joining us for today's SQL Server Query Tuning Best Practices webcast. We recognize that you have a lot of different ways you could be spending your time, and so we're grateful that you have carved out a bit of your day to spend it with us, and we hope to give you some value back for your time by pointing out some tips and tricks that will make you more effective at writing your SQL queries. We've got some cool things going on, so let me take a minute and tell you about some of those sorts of things. The first thing I want to tell you about is, in case you didn't know, we have a website called SQLperformance.com. Aaron is the editor-in-chief there, and the quality of articles over there is just amazing. Really, really outstanding stuff. And one of the things we decided to do is not only to put this SQL Performance website out, but to turn many of those best articles into an ebook. So our very first ebook out of the website, High Performance Techniques for Microsoft SQL Server, written by Aaron, editor-in-chief, and many of the top experts in the industry, folks like Kimberly Tripp and Paul Randall, one of my favorite query tuning experts, Paul White, Jonathan Cahias, Joe Sack, Glenn Berry, as well as a lot of just fantastic stuff from Aaron as well. Almost 300 pages in length, chock full of outstanding Transact SQL and SQL tips and tricks. Really, really good. Just by attending today, just by registering for that matter, you are going to get a promo code that will enable you to download this book for free. It will be available on the Kindle bookstore, the Amazon Kindle bookstore, so people can buy it if they want to. But because you're a valued customer of ours and you're taking part in our community, we want you to have that for free. And then in the future, we will also be putting out more of these as we build up more content on SQLperformance.com. Just a quick plug too for Aaron and his group. Do spend some time and read the blog post there. It's a great website, and one of my favorite parts of it is http://answers.sqlperformance.com. It's a discussion forum, and there's a lot of really cool stuff about how to tune your SQL statements, and particularly using execution plans there on the answers portion of the website. So that's neat. One other thing we're doing that's also really neat, but is a source of infinite disappointment for Aaron and myself, is because we are not eligible to participate in this, is we're just so excited that the Professional Association for SQL Server, the big PASS Summit, the biggest SQL Server event of the year, is coming to Charlotte in October. And one of the things we have decided to do, since Charlotte is both our hometown, that's our headquarters at SQL Century, and it's also the headquarters of NASCAR, we thought, wow, what a great way to bring those two together. So everyone who attends today will get a raffle entry into our big giveaway that will be taking place at the PASS conference for 3 driving experiences, 3 rookie experience packages from the Richard Petty Driving School, and then 3 ride-along packages. So 3 folks will win the opportunity to drive one of these race cars at 220 miles an hour, and 3 folks will get to ride along in stark, abject terror as well, either with a professional driver or with perhaps one of the others. So just some really, really neat stuff happening there, and we hope you'll spread the word for us too, because if you're going to come to the PASS event, wow, what a great way to spend that time. And I know that I personally have gotten out on the yacht at some pretty high speeds, but nothing like what you can do in one of these performance NASCAR things. Aaron, have you ever been out on the Autobahn?
I haven't been on the Autobahn, no, but I've driven those speeds before.
Just heading out to the target from home.
Yeah, pretty much,
Hit
pretty
it.
much. In my 20s.
Yeah.
I don't do that kind of thing
Oh,
anymore,
okay.
but yeah, I've definitely been in the 130, 140 mile an hour range.
Wow, you're a braver man than I. Well, we've heard a little bit about Aaron and myself. We're old friends. We are both very long time SQL Server MVPs. I just got my 10-year award. Aaron was one of the very first crop of MVPs. I think you were ASP MVP at first, weren't you?
Yeah, starting in 97.
Wow. Yeah, yeah, that's amazing. So yeah, longtime SQL Server people, and just really proud of what we're doing here at SQL Century. Some really neat products and tools, and we'll put some more attention on that towards the very end of our presentation. Today, what we're going to talk about is right off the bat. The first thing I'm going to do is spend a little time about how to approach your SQL query tuning methodically from a methodology, a process standpoint. And I'll also go a little bit into what it takes to analyze the different touch points along the way as you look at a set of SQL queries. And then Aaron is going to jump into some really interesting patterns and anti-patterns. If you have been joining us for the other monthly presentations we've been doing on query tuning patterns and practices, some of this will look familiar to you. But we're doing the whole presentation series from start to finish again with some new tips and tricks throughout. So hopefully you'll also get some new information. So with that, let's talk about our methodology, or in this case, our meatheadology. My friend and colleague Lori Edwards is shaking her head in shame at the terribleness of that pun. So the first thing you have to do is you have to configure your test environment so that it's stable and predictable. You want to make sure that you know what normal is for that environment. You know what it looks like at rest. So you have to take some initial measurements. The next step sounds very simplistic, that you run the test, but there's actually a lot going on behind the scenes with that. You need to be able to take measurements that let you compare, I guess you could say, the same metrics. Make sure that the tests that you're running are apples to apples. Not apples to oranges. We're not actually looking at different things. And then finally, we have to, take a stroll through the different bits of information that we've collected, and we have to know what to look for in that information so that we can make some, some strong determinations of, what is working well and what isn't working in our particular SQL statements, all different alternatives throughout. So when I get started, that very first step is setting up the test environment. And when we set up the test environment, again, the idea is to ensure stability and consistency. And you do that with what folks use different terms for it, but use a test harness or maybe a test jig or a testing script. I've heard all kinds of terms for that. But in my case, let me tell you a little bit of a story. When I was first getting started with doing, I had been given a whole set of SQL stored procedures that I needed to tune. And when I started to work on the different SQL statements, I ran them to see what kind of result sets they returned so that I could, make sure that all the result sets are identical between different versions of the queries that I was writing. And I made some changes. So I ran them, and then I made some changes, and I ran them again, and it was just enormously faster. And I was thinking, wow, I'm a Transact SQL god. I am so good at this. The changes I made just, they made performance so much faster. And one of the more senior fellows who worked there, who was kind of my mentor, walked by and he said, "Yeah, Kevin, tell me, how did you handle all the caching of the data?" And I said, "I beg your pardon? What is this caching that you speak of?" And he said, "Yeah, all that data has been cached in the buffer cache, and so the second time you ran the query, it didn't have to put anything in the buffer." And I thought, "Oh crap! All that work I did, and I have no idea whether it was actually the improvements I made, or whether it was the fact that the data was already loaded into the data cache. And as you can probably guess, that was what made it faster. It wasn't that it was that much better. And for a long time in SQL Server, you could only clear the caches by cycling SQL Server. You actually had to stop it and restart it. And boy, oh boy, what a horrible way to try and manage your cache that way. As it turns out, now in SQL Server, pretty much from 2005 and later, we are able to use some DBCC commands. So we can say DBCC free proc cache or free system cache to clear out the different plans from the plan cache, or we can use flush proc ndb. Now this is an interesting one. If you are in one of these situations where you have you know, a kind of a dev environment, you have a lot of a lot of databases on the same box, you can actually you know, give one database to one group of servers and another database to another, to a group of developers, and another database to a different group of developers. This way they can clear out the procedure, the plan cache, without impacting anybody else. Or you can clear out the whole procedure cache at one time. And then there's also this drop clean buffers command. So the drop clean buffers command is really useful for clearing out the buffer cache. Again, don't do that in production. You know, that's going to really mess up anybody who's, you know, depending on cached results to get good performance. But if you're actually just in a dev or test environment, or maybe you're working on your own little local workstation, then do make sure that you clean that out each time. Or there's another alternative. So what I'm talking about here in these first couple bullets about code to clear out your caches, that approach is called cold cache testing. So you want to make sure that your cache is cold every time you run the query. You know, that means there's nothing in it already. It's cold. It's not warmed up. So that you have an idea of the full amount of time it might take to run that query, you know, to actually get the data from disk or whatever the stored subsystem is. Maybe it's SSDs, to load that up into RAM, into the buffer cache, and then to return it to the user. An alternative, maybe if you are on an older version of SQL Server, SQL 2000 or something, is to do what we call warm cache testing. And so instead of issuing these commands, what you would do is you would actually run your query, say 2 or 3 times, just to make sure all of that data is loaded up in the cache, and then take measurements on that second or third run, so that now you're comparing each variation of your query tuning to the warm cache numbers. You know, everything's in data, in the data cache consistently. So now when we take the measurements, at least we know it's going to be similar, you know, for each variation of the query that we try. So those, it's very important to you know, prepare your environment. The next step is to take some measurements, and different people have different favorites. In my case, I really like to use the set statistics time and set statistics IO. Those are both kind of essential for me. In addition, you could also use something like set show plan text or set show plan XML and turn those on. You don't have to do any of these to get this information. You can actually use the GUI and flip a switch in the options panel of the GUI to show what those are. But in my case,
you could also use Plan Explorer, which does these for you automatically.
That's right. Or you could use the free tool called Plan Explorer from SQL Century that will take care of all of that stuff for you. And you'll see that as we're running along through our different demos in just a minute. Now, the last thing also that I like to do when we're doing this different kind of query testing is to check your different, I guess you could say your different DMVs, so that you could look at different metrics to know how the queries are actually impacting performance. You know, what resources are they consuming? What are they doing? Now, set statistics set statistics IO will show you what IO consumption a query has, but you get a lot more information out of a variety of DMVs, and I mentioned 2 there, sys DMOS performance counters and sys.os weight stats. Those are both excellent, and you want to get to know those DMVs. But there's other ones as well. And again, just like Aaron said, in Plan Explorer Pro in particular, we actually also keep track of what those weight stats are for a given SQL query. So you can see that in the tool, or you can go after this information yourself if you're kind of rolling your own solution to query tuning. Now this is the periodic table of SQL Server dynamic management objects, and it's written by a friend of ours named Tim Ford. Tim runs a really fun training event called the SQL Cruise. And Aaron, you just got back from a SQL Cruise.
I sure did. I'm still on Alaska time, actually. I just got back on Saturday. It was a great event, as it always is.
So, just for a brief digression, you were a week at sea, did a lot of training?
That's right. A lot of training, and then there's also some downtime too. So on the Alaska cruise, there are 4 ports. We stop in Ketchikan, Skagway, Juneau, and Victoria. We have to make port in one. We call it international. It's just Canada, I guess, for the cruise to operate. So there's we have half a day, give or take, at each of those ports where you get downtime and you get to go and do excursions and see the scenery and a lot of wildlife and that kind of thing. And then the rest of the time is spent with the other cruisers, either doing training or we have some career-oriented events and downtime where we just basically talk about our professions, or sometimes not our professions, as opposed to doing specific SQL Server training.
Right.
So it's a pretty well-balanced event.
Fun. Well, that's called SQL Cruise, folks, and I encourage you to take a look at that, SQLcruise.com. So, written by Tim Ford, this particular set of, it's laid out like the periodic table in chemistry, and so you can see there's a lot of different dynamic management views and dynamic management functions. That's SQL Server's way of revealing its internal instrumentation and its behavior behind the scenes. A lot of them, and not all of these actually apply to us when we're doing query tuning. In fact, unless you're doing performance tuning in general, you might not be spending much time with the dynamic management views, the DMVs. But for query tuning, there are going to be 5 that I'm going to point you to particularly. The first is DMOS weight stats. In SQL Server, a weight stat, SQL Server basically from 2005 and later, it categorizes every time that SQL Server has to wait on any kind of resource to complete a particular set of operations. Those are called weight stats or weight statistics. So you can tell very quickly what your major bottlenecks are by looking at your DMOS weight stats. This is really, really useful because you can see, is it related to I/O? Is it related to CPU? Is it related to locking and blocking? Maybe somebody wrote an update statement that, just locks a whole lot of stuff. So it's the kind of thing that it really is very, very valuable to determine if your SQL statement or statements aren't performing well, what's the general category of bottlenecks that are happening. There is a little caveat about weight stats, though, is that they're not always easy to understand. They're not always sensible. So you need to study a little bit about what the different weight stats mean. There are some of them that are just completely natural, that occur all the time and always kind of tick upward as long as the server is up and running. Those are kind of natural organic things like a heartbeat or respiration. So some of them you might get alarmed at because you see it's increasing dramatically, but it's normal. So you do need to learn a little bit about weight stats to use it effectively. And the other caveat about weight stats, and I know this is something that Aaron and I have talked about a lot, is that weight stats don't show you the full picture. There are things inside a SQL Server that aren't really, I guess you could say, fully described by what it's waiting on. You know, one example of that is kind of a famous weight stat. If you read blogs a lot, you'll have seen or heard of a weight stat called CX packets. CX packet weights, context extension packets is what that stands for. And people say, oh my gosh, that means you've got parallelism in a bad way. That's not necessarily true. There's a great big asterisk by that. So a bit of a caveat on you know, just taking a full assessment of your entire environment just based on one or two weight stats, something like that. But it is extremely good for getting you into the general category or the bucket of what your bottleneck is. Another one that's really good is the DM exec query stats. So this gives us query related performance information for each of the different queries that are going on. It tells us a lot about the system resource consumption on a per query basis, CPU, memory, I/O. So I'll show you an example of that in just a minute. Another key point, and Aaron's going to show a little bit about this in his demos in just a minute, but there's few things that impact query performance as significantly as indexes. So knowing a lot about your indexes is going to be key to you being a top flight SQL coder. And so the way you find out about SQL Server indexes is using the DMV called DB index usage stats. And so this is a really good DMV to show you how many index seeks are happening, how many index scans, like a system scan, a user update. You can see, very granularly what is happening on the system, or on the index, both from a system point of view and from a specific, from the end user point of view, I should say. And there's just two more I was going to mention. The I/O virtual file stats. This is important because I/O, the speed of your I/O subsystem tends to be, we find, probably the single most frequent hardware breakdown. This is the most frequent hardware bottleneck for most computer systems. Sometimes it's network, or sometimes it's CPU or memory, but if I were to bet, knowing nothing about your system, and you said, hey, it's performing poorly, I'd say it's probably your disks. And so the DMIO virtual file stats DMV tells us a lot about all the SQL data and transaction log files, how they perform, how big they are, all that sort of stuff. So this can tell us, if you're doing a query in a particular database, is there something that correlates all the way down to the disks, the way that database and transaction log is saved to the disk? Is there some kind of correlation between the performance of those disks queries? And then finally, the DM exec requests DMV. And this is what user by user are doing. And you have to combine this with some other information typically to get what you want. But this tells what the users are up to at a particular time. And so let's take a look at each of these really quickly. I want to give you a little bit of an idea about how to look at this data. So let's just take a quick look at some of these. So in this particular query that we have here, and again, these are all examples from Tim. Tim is the co-author, Tim Ford is the co-author on a really nice book from SimpleTalk, along with a friend of mine named Louis Davidson. And it's called, gosh, what is that one? DMV for troubleshooting and performance tuning, or something along those lines. So just look at simpletalk.com and look for Tim Ford, and he has a variety of these different queries that you can reuse, and they're also in our slide deck, so you can see those as well from the slide deck.
It's called Performance Tuning with SQL Server Dynamic Management Views. I can see my bookshelf from here, so.
Oh, outstanding. So here we can see in this particular one, this is the DMV that we're interested in. These two dynamic management functions are the difference between a DMV, a view, and a DMF, a function. The functions, you have to pass in parameters of different sorts. So here I'm going to take a look at the SQL Century database, and if I execute this, it's going to give me some different different information here. But you can see in these different columns below the average CPU, the average total time in milliseconds, the average number of reads and writes. And those reads and writes are in 8K data pages. And then if we expand the request out, you can even see, what those different SQL statements look like. And of course, if you wanted to sort any of these, you could also sort them by, whatever the column name is. So maybe you want to look at those by CPU. So we could say, select or order by average CPU time. So this is a great way to see, if I ran a stored procedure that had 5 statements in it, I could take a look at this and see which of those are consuming the most resources, and then use that information that's retrieved here to determine which of those different select statements or inserts or updates or deletes that I might be focusing my attention on first to help me kind of prioritize. I'm going to skip down to one on index usage stats. So again, you do different things like filter out on base you're interested in. If you, Aaron and I were just chatting about this actually, the index ID of 0, tell me again what that one means, Aaron.
Index ID of 0 is a heap. Index ID of 1 is a clustered index.
Okay, so let's just have it tell us about all of the indexes that exist right now in the SQL Sentry database. And so if I look at that here, I can see how many user reads and user writes. So this is telling me about the end user activity against these different indexes, and you can see it's a really long list. There's quite a few different ones in there. If I were to go ahead and say, let's take a look at just those heaps. Well, a well-designed database seldom has a lot of heaps in there. Okay, and so in this case, we've got just one table, and I bet you it just has 1 to 5 rows in it. What's your license key? Something like that.
It's probably just a single row, I think.
Yeah, probably just a single row. If we go with the clustered indexes, so we can change that index ID to 1, and then you can see exactly what the table name is and how many reads and writes are happening against the different clustered indexes in this particular database, the one we specify here. So again, this is telling us how busy these different indexes are. But as I mentioned on the slides, there's different information in there. You might want to know how many seeks are happening, index seeks. If you have an index that isn't getting any seeks on it, that's a bad indicator. It's not being used the way that that maybe it is intended to be used. And then here's another really useful query. This particular one, DMIO virtual file stats. And this is when you pass the null variables in, that's just saying, tell me all about everybody, not for a specific database or file. So here in the results down below, you can see it is retrieving all the information for all of the different databases for their MDF and LDF files. And it's telling you the number of reads and writes, the number of, the amount of time that's stalled, the amount of data by volume, so the size on disk, the number of reads in bytes. Again, how busy are my indexes? And just one additional page here to show you as well. There's no need for you to write your own query about weight stats, at least to get the basics. There's a blogger who also writes at SQLperformance.com. He's coming out in our new ebook, Glenn Berry. And Glenn has some great, they're called the SQL Server Diagnostic Queries, and he's got some great queries in which one of the things he does for you is he has included in the not subclause here all of the things that are just kind of natural parts of the SQL Server weight stats. These are all organic things that we don't want to find out what the request for deadlock search is. So use his queries, and when you use those, you'll see what your weight stats are, but the ones that are actually kind of significant in terms of accumulating IAO work. So in my case, actually, this write log is probably the most significant for for this particular server, I'm spending a lot of time waiting for my transaction log to be able to deliver the right throughput that I need. So those are some of the sums I wanted to show. Just on the point about the test harness, and I gave you the code for that in the slides, but you can also come in here to the query options and set them under the advanced tab. So you can set things like set statistics time just with a checkbox there, set statistics IO and so forth. So you can set these graphically if you don't want to do them with SQL text, but I do encourage you to use that Transact SQL. All right, so let's flip back to the slide deck. And I promise I'm not going to be talking too much more. When you get your, when you run your set show plan text, or maybe you flip that box, or you're looking at the graphic execution plan, hopefully you're looking at the free Plan Explorer tool that we provide for free. You'll notice certain things will be highlighted in red. So we take the guesswork out of it. We actually flag some of these things in red for you. But if you're not using that, you want to look for query operators in the execution plan that are things like lookups. In older versions of SQL Server, you might see something like a bookmark lookup. In the newer versions, it's going to say a key lookup or an RID lookup. So those are often indicators that there is an indexing opportunity that could be taken advantage of. Not always, but in some cases, scans can be bad. If you have a really, really big table and it does have a clustered index on it, and it says clustered index scan. I remember the first time I saw that decades ago, and I thought, oh, that can't be too bad because it's using an index. And then I realized, oh, wait a minute. Every single record of the table is in the clustered index. So some can be bad, but some, not always. There are exceptions to that rule. I'm always on the lookout, too, for spooling operations like a lazy spool or eager spool, and certain kinds of parallelism operations are also kind of alarming. These missing statistics alarms, they don't show up in the execution plans necessarily, but those are important. Missing index alarms in the later versions of SQL Server, that's also something that you might want to pay attention to. One of the ones that I think is not widely known by a lot of people is that SQL Server, when it keeps statistics from the various indexes and so forth, it will make a guess on its execution plan. That's called an estimated execution plan. And then there's the actual execution plan. And one of the reasons I always like to pull both the estimated and the actual execution plan is because anytime I see that there's very dissimilar numbers for what a particular step in the query process produces in terms of the number of records, if it's very dissimilar between the estimated and the actual, then that is a waving red flag to let you know that the statistics are somehow wrong. They're out of date, they're very stale, something like that. So you're going to see this in action in just a minute. What we're going to do now is Aaron is going to take you through some patterns and anti-patterns. We have a lot that we are going to talk about throughout the course of many of these presentations over the next few weeks. But today, Aaron is going to talk about a few of these in particular. So these are kind of teasers for what you're going to be seeing not only just today, but in the future. So you'll be seeing some more of these. So Aaron, why don't you take it away and tell us about some of the patterns and anti-patterns.
Sure. So I see a lot of common anti-patterns in SQL Server. Some things that people do a lot, and they become habits that tend to proliferate through their code, even though in a lot of cases they can do bad things. And this is not just code that I review for customers, but also questions I answer on Stack Overflow, dba.stackexchange, and this goes way back to even the Microsoft newsgroups. Some of these core problems and situations come up over and over again, even if some of the details change. So we have this list of patterns and anti-patterns here on this slide. We're going to cover a few today, a couple that aren't on the list. The list is much bigger than what you see on the screen right now. So today we're going to deal with 3. The first one that never goes away, is people's tendency to use cursors even when they aren't necessary. So they seem to be a knee-jerk reaction in a lot of cases for folks who think procedurally, or in terms of acting on each row instead of on the set as a whole. So that'd be on the next slide there, Kevin. So yeah, so cursors are usually unnecessary, but I realize that a lot of times, they have their place, and I could list many examples where they are perfectly valid, or where the effort to convert them to set-based code would not have a big enough payoff. And yes, a while loop is a cursor. So a lot of people believe that if they change their cursor to a while loop, that'll magically get rid of the cursor. It's not the case. A while loop is still a cursor under the covers. It just doesn't explicitly say cursor. And no, a while loop isn't any faster than a cursor, which is a pretty common myth, just to get those out of the way. Now, I don't expect anybody to go out and change all of your cursors to set-based code just because I said so anyway. But I'm going to tell you about a much simpler change that you can implement very quickly and make those cursors that you are using much less painful, even if you don't have the time to invest right now in changing them to set-based code. So the defaults for cursors in SQL Server are they are global, they're dynamic, they're updatable, and they're scrollable. These are all very resource-intensive options that are rarely required. Almost every single cursor I've ever seen in the wild has not needed any of these options to be set. Typically what people are doing is they're using a cursor to loop through a result set exactly once, going forward, and aren't using the cursor at any different scope than the current one. Usually they are just obtaining individual values from each row and firing a stored procedure or otherwise acting on that value without directly updating the cursor using where current of, without having the need to go backwards and forwards within the cursor. It's basically a fire hose. So shoot through the list once and then you're done. There's a blog post here on this slide where I've talked about this pretty extensively, but I'll show a quick demo of that in a couple of minutes as well. The next slide is one about correlated subqueries. So people often want to select from one table and then also pull some aggregate or other data from another table, but they don't want to write a join or add a group by or any of these other complex query constructs. So they include subqueries in the select list to pull the data, not realizing that it can lead to a much more expensive query. Sometimes it's the same or no worse. If you're only pulling one result, for example, it would be equivalent to a join. But a lot of times I see this pattern used and it stacks up. So they need to pull a second value, so they add a second subquery. And then they need to pull a third value and they add a third subquery. So I'll show an example of this and a couple of potential rewrites and a very dangerous rewrite that people might tend to use. And then the third demo that I'm going to show is about the not in pattern. So this is where users want to find, say, all the patients who haven't had a flu shot or all the customers who have never placed an order. All kinds of things can go wrong here. For example, the checked column that's inside the not in clause could be nullable. So in this case, the query is basically asking, is this not unknown? And the answer, of course, is yes, because unknown is unknown. So what happens there is null rows are included in the result. The reasons for that are a lot more technical. I don't want to go too far into them, but the end result is when you say not in and the output column is nullable, you're going to include those rows where the column is actually null, which isn't exactly what you meant when you said, is this value not in this set of values? A lot of people will rewrite that not in as a left outer join and check that the right-hand column is null. But similar problems can happen here unless you're very careful about selecting which columns you're checking for null. You can also use except, but there are a couple of side effects. One is that the shape of the result set must be the same. So it's tough to say select first name, last name from customers, except select first name, last name from orders, because first name and last name don't exist in the orders table. So what you would have to do in that case is use except with a much more complex derived table of some kind that pulls out only the columns you need to use in the accept, and then you still have to go and perform a join to go get those extraneous columns that aren't common to both tables. Accept also implements an explicit distinct, an implicit distinct. So the distinct happens and you don't really know about it. So it may not always produce the same results as not exists or left out or join equivalents. I've vlogged about this one as well pretty extensively, but I'll also show a small sample demonstrating. So I'm going to take control, and hopefully you can see my screen.
Sure can.
So the first example, I'm going to start with a cursor, and I'm going to actually run it, and then I will explain it because it takes a few seconds to run. So essentially what I'm doing here, as Kevin talked about, I'm dropping clean buffers so that warm cache doesn't influence my results in any way. Next, I'm declaring a couple of variables, one to keep track of my time, and one just as a variable placeholder. Now I've got a cursor here that I'm declaring, right? So I'm just using the default options, declare C cursor for, and then a query. And this is very simple. I'm selecting the top 500,000 rows from a big sales order header table. I'm opening the cursor, fetching the value, and then in the cursor loop, all I'm doing is playing with that variable a little bit. I'm not storing it, I'm not printing, I'm not doing any output, nothing else. This is just a very simple loop. Close and deallocate the cursor, and then I tell us how long it took. So if we look at the results using the default cursor, that took about 10 seconds, right? Pretty simple, but that took a long time to go through that loop, knowing that I haven't really done anything with the data. I haven't even presented the data. I've just processed this cursor.
Yeah.
So now let's see what happens when we add a couple of keywords to the cursor declaration. So instead of global, I'm going to make the cursor local. And that just prevents the cursor from being exposed to outer scopes. So if this was in a stored procedure, the caller would be able to reference the cursor if I didn't use the keyword local here. So it's kind of like a temp table, right? If you create a temp table inside of a stored procedure, the caller can reference that temp table outside or after the stored procedure is finished, unless the stored procedure has explicitly dropped the temp table. This local keyword is essentially like dropping the cursor as soon as you've closed and deallocated it, instead of leaving it open and leaving it referenceable by outer scopes.
Okay.
And the other keyword I'm adding, is fast forward. This makes the cursor read only and not scrollable. So it's combining read only and forward only into one keyword. Everything else is the same. So let's run this and see how long it takes. And that took 5 seconds. So by adding those two keywords, I haven't changed anything else about the query. I haven't changed any semantics about what I'm doing. The cursor's the same. The loop is the same. It's just a local fast forward cursor, which, as I said before, matches at least 99% of the cursors that are out there today. And I cut my execution time in half. That's a pretty substantial savings.
Wow. Yeah.
Okay, so on to subqueries. So this is a pattern I see quite a bit. We've got, I'm pulling customers, let's say, from the customer and person table. I'm not going to make comments about the funny schema in AdventureWorks. I'll leave that to Stacia to explain. Stacia Meisner is one of the authors of the AdventureWorks schema, but I don't know if she'll readily admit that to a lot of people. So the type of pattern I see is we're getting this information from the customer tables, and then we're pulling in metrics about their order history from the sales order header table. And in this case, it's sales order header enlarged, and I'll talk about that at the end. So basically, we're taking, what I want to know is how much has each customer spent total for all time, and when did they place their last order? So these are metrics you might feasibly want to get. I've tried to make this query as realistic as possible. These are two metrics that you might want to try to get when you're trying to understand your customer base. And this is the pattern that a lot of people will use. So instead of adding a join to the sales order header enlarged table and then having to group by all of these columns, they find that this is a lot simpler. So we'll make a correlated subquery in the select list that goes out to the sales order header and large table and grabs the data for each customer in the result. Now, the way that some people would probably write this, if they're thinking a little bit better about how these subqueries can stack up, is to write a join. So we add the sales order header and large table to the join, and then we group by. So we take the sum and the max without all this correlated subquery stuff. We just take the sum and the max, and then we add the group by at the bottom. Now, one of the ways that I would typically write this query is I would go out and pre-aggregate using a CTE so that I don't have to group by all of these columns. And because grouping by first name and last name doesn't really make sense. It's not really what you're grouping by, but you're forced to group by those columns because of the aggregation that you're doing. So I'll pull out the aggregation using strictly the columns that are necessary. So in this case, it would be customer ID and person ID. And the reason person ID is required is because that's how we join to the person table. Right? So I'm trying to restrict the amount of reads I'm doing to perform the aggregations and restrict the number of columns I have to repeat in my group by clause. Mm-hmm. So here I'm taking the sum and the max, just like before, taking the sum and the max, but against just these two tables. And then using the CTE, I'm pulling that out of the CTE and then joining to the person table. Now, when I join to the person table, I know it's a one-to-one match, and I don't need to do any grouping or aggregation anymore. I've already done the aggregation inside the CTE, and now it's just a straight join. I don't have any group by on the outer here. I no longer have to group by the first name and last name like I did in the join up here.
Right. More
now,
elegant
another
solution.
way that might be right. Yes. It's kind of both. So it's a little bit less elegant because you have this separation now of clauses, and you kind of have to mix things up a bit. But it's a little more elegant because you don't have these unexplained groupings, right? So you can have two customers named John Smith, and because the customer ID is already unique, grouping by those additional John Smith columns, even though you have two that are the same, you're not really grouping by them at all, are you?
Right. And just as a little aside, you might also address this too, Aaron. A lot of people seem to be curious about CTEs in general, and they, sometimes they'll approach CTEs as if they're going to be a much higher performance kind of construct than, say, a view or, a general SQL select statement. You want to give a quick thought on that?
Sure. So there are a couple of things that happen with CTEs, and there's one in each direction. One of them is people think that a CTE is like a temp table. So when they build some query inside of a CTE, it will only ever be executed once. What actually happens is the query that's inside the CTE will almost certainly be evaluated for every single time you reference that CTE. So if you stack your CTEs and you reference the previous CTE in multiple CTEs or in the query down below, or you have a correlated subquery that also references the CTE will actually be executed that number of times, however many times you referenced it independently.
It's basically
so that can.
It's a lot like a view, right?
Right. It's basically an inline view is what a CTE is. Now, on the flip side, a lot of people will say, oh, well, I wrote this CTE once and it killed my performance. So then they have this fear-mongering attitude where they say, don't ever use a CTE because it sucks for performance. And what actually happened is something that had nothing to do with a CTE. If they wrote that as a derived table, it probably would have done the same thing. Or perhaps they wrote a recursive CTE and their recursion was way had a much deeper cycle than they thought, or all kinds of things can happen there. And the problem is when someone has a bad experience once, they tend to extrapolate that and say, oh, well, this is always bad. And I don't want anybody to be scared of CTEs because one person had a bad experience or maybe improperly coded a CTE and have this opinion that they're bad.
Okay. That's a lot like me and circus clowns.
Yes, I would agree. So speaking of CTEs, another way that might be tempting is to use window functions instead of grouping. So if we look at this example, I've got a CTE here that selects the 4 columns, well, the three of the 4 columns that I'm interested in. And then to calculate lifetime sales, I do a sum over, right? So a sum of total due, and then I partition by customer ID. So this will give me a sum for each customer, but notice that I don't have a group by here. So the window function allows me to perform that sum without actually grouping. So I don't have to group by all of these columns when I know that my grouping really only involves this customer ID column. And then we have the order date, and then we can also use a row number, for example, to partition by customer ID and order by the order date descending. And this will tell me which result in this set represents the earliest, or I'm sorry, the latest order date, right? So we calculate all of this information using the window functions inside the CTE, and then outside we filter. So we get all of these columns, and we filter where this row number is 1. So the newest order date for each customer. So we'll flip over to Plan Explorer and take a look at and see how these work.
And so all of these queries produce the same result set, but they're going to have probably massively different execution plans.
It's possible they will have different execution plans. Yes, they produce the exact same results. So we'll get the actual execution plans. Should take about 6 seconds, I think. Maybe 10 seconds. Maybe my computer's getting slow. Okay, here we go. All right. So we have this first version is the one with the 2 subqueries that were stacked in the select list. And we can see that the query performed 2 clustered index scans, right? And that makes sense. If we had added a 3rd subquery in there that had to go get aggregates from that table, we'd have to perform another clustered index scan. So the explosion of this query, if you will, is linear, right? So we perform an additional clustered index scan for every subquery that's in there. Now, the problem is if you have much bigger tables that you're pulling data out of, and you have a variety of tables that you're doing this from, it makes the query much more complex, obviously, but it can also really increase the cost without you realizing it until you've run the query. If we look at the join and CTE methods, they're roughly equivalent. They've got half the number of reads because we only performed 1 clustered index scan, and the duration is about half as well. So it's a little slightly higher than half, and I bet if you flipped a coin and ran these 100 times, 50 times the CTE would come out faster than the join. These are very small numbers in the grand scheme. Now,
Sure.
If we look at the CTE that had all those fancy tricks in it, this is a much more complex plan, right? So there's a lot of stuff going on here. We're introducing table spools. We're introducing really expensive sorts. We're introducing hash matches. And we've got 2 clustered index scans that don't cost all that much, but they're there.
Right.
There's a lot more going on here. So window functions can sometimes make your query structure a little simpler. So I didn't have to add group by to get all of these aggregates, but it came at a significant cost, right? So we've got, the query cost. I don't pay too much attention to the percentage numbers, but look at the duration.
Yeah.
It's almost 10 times, right? And then the CPU is a lot higher as well. Look at the reads, 2 million, almost 3 million reads versus 60,000 and 30,000 for the other 2 approaches. So you can do things that make you seem a lot cleverer and have a slightly more compact query statement, or a more complex query statement that's less to type but more complex to look at. And it doesn't always necessarily produce a better result.
Right.
So that's just one example where some fun things happen.
And a kind of a correlated point to that too, Aaron, is that windowing functions are new in SQL Server 2012. So one of the things that Aaron and I both keep saying over and over again is don't just automatically switch to the newest, shiniest thing just because it's new. Know what business cases it's intended to solve and apply it accordingly. Just because it's new doesn't mean it's going to be the best way to go.
Right. So, the original windowing functions like row number and dense rank, those were introduced in 2005. 2012 introduced a whole bunch of new ones thanks to EXEC. And a lot of them are very useful. They get you the answers you need without having to perform multiple queries or to perform really complex queries. But like Kevin said, in some cases, they're not better. I have a blog post on SQLperformance.com about medians, and the new percentile functions that were included in SQL Server 2012 are actually much worse at calculating medians than existing methods. So just because it's shiny, just because it's slightly less code, make sure you test that against the method you're using now to be sure that it's actually a better option. It's not always going to be the case.
Right.
Right? They don't improve the performance of every single use case.
Well, we've got about 5 minutes to go. Tell us about
really?
the not in stuff. Yeah.
Okay. So not in. This is a pattern people use a lot, and one of the problems is that you can have incorrect results if the column inside the not in clause is nullable. Thankfully, in this case, it's not true. Customer ID in the sales order header table is not nullable. But I still find that a better approach is to use not exists. So this is essentially the same query pattern. It's going to produce the exact same results. The thing I like about using exists or not exists compared to in or not in is that the result inside of the clause can short circuit. So all it has to return is true or not true, whereas the in and not in, they have to materialize the entire result set. So at the very worst case, not exist is going to perform the same as not in, and in some cases it will perform a bit better. I talked about except, and so in this case we're only looking at customer ID, so we can do this. In a lot of cases you won't be able to do this. So select customer ID from sales.customer, except select customer ID from sales.salesorderHeaderEnlarged. This is, again, same results, just a slightly different query pattern, where we're saying give me the customers that aren't in sales order header enlarged. And then we've got various ways to do a left outer join, and depending on whether the column that you're checking in the right table is covered by an index or is nullable or is perhaps a lob column, can really impact the results. And I will show that by switching to Plan Explorer without belaboring too much. So we just looked at all of these queries. Here's not in, not exists, the except, and then 4 different left outer joins. One is on customer ID, which is the key and covered by the index. One is on sales order ID. One is on total due, which is nullable and is not nullable but is not part of the index, and we'll see how that affects it. And then comment, which actually is nullable. And if we look at the results, I'm not going to run it again, just in the interest of time. But we see that, if we go to the plan diagrams, so the not in and the not exists, in this case, produce identical plans, and they also produce pretty identical results. And the except, same thing, very similar plan and similar duration. Now, when we get into the left joins, no matter which one we use, we see that the performance is quite different. So as soon as we start using left outer joins instead of the first 3 patterns, we see an escalation in duration, and we also see lower reads. Now, this is interesting because on SQL Cruise last week, I had a conversation with someone who said, I always look at reads to determine when I'm comparing different queries to determine which one is probably going to be my worst performing query. Well, in this case, we've got reads of 66,000, 3,000, and 30,000. But then look at the correlating durations. So I tend to look at what my end users are going to look at first. And end users don't really care what this read count is if the duration is 10 times or 100 times longer, right? So just a case as a counter example where we see here that a high number of reads doesn't necessarily mean low performance. One last thing I'll point out here is that when we used a nullable column in the left outer join, when we check the right-hand column to be null, we get the wrong results. So all of these queries return 701 rows, except for the one where we used a nullable column as the check column. So this included all of the rows where the column matched, but was actually null. So you can't really tell the difference whether the column was null because it didn't match or because it matched and it was null. So for these reasons, I always stay away from the left outer join patterns. I'll prefer not exists over not in, and for simplicity, when I can, I'll use except. And I think that's about all I have in the way of demos. Kevin, would you like to take control back?
Yeah, and just to add on to what you were talking about from there, make sure you do look at all those different factors. Just like you said, if you're tuning an update statement, then that's a read-heavy operation possibly, but it's also a write-heavy operation. So measure what is significant to the end users. So much of the time we think of what we do only as technology related, but at the end of the day, what we're really being employed to do is to solve business problems, and we're just using technology to do that. So sometimes we don't need to be over-engineering a technological solution for a business problem that might involve something very simple. Great demo, Aaron. Thanks so much. That's really useful stuff. And folks, just like we have here on the screen, read this blog post. I don't mean to embarrass Aaron, but this is one of my favorite blog posts in a long time. It's a very good, very informative, and very kind of systematic proof of these different techniques and which works best. All right, so we're right at the top of the hour. Thanks everybody for sticking with us throughout. Very pleased to have you with us. And just a couple quick follow-ups. If you're active on Facebook or Twitter, please follow us on those different networks. If you're on LinkedIn, for example. Also, we've got a website at SQLcentury.net, and as we mentioned before, SQLperformance.com, as well as the answers component of SQLperformance.com. One of the neat things you can do with our cool free Plan Explorer tool is you can actually upload your execution plans to the answers.sqlperformance.net website, and incredibly brilliant people like Aaron and Paul White and other MVPs will give you some feedback on it. So in a way, it's almost like free consulting. And then also we have a variety of other tools for monitoring, event alerting and alarming, things like fragmentation management and disk-based management for your SQL Server databases. So those are all available in entirely free trial versions. They've got all the features. They're just time limited. So would love for you to download some of those, give them a try. And if you're interested, schedule a demo with me and my team. We'll be happy to spend some time with you, show you how to use the tools, how to make the most out of them, and get some good value out of those too. In particular, I'm going to put Lori Edwards to work on endless demos for you, so she's shaking her head no at me across the table. Okay. Aaron, great stuff. Thanks so much for your time. Appreciate it. That was a really good set of info. All right, and on Aaron's behalf, along with everyone at SQL Century, thank you so much for your time as our attendees. We appreciate you joining us. We have got another one of these strictly query tuning sessions every week, pretty much for the next 2 months, with the exception of the U.S. holiday, a couple U.S. holiday weekends coming up this summer. So hope that you will join us for more of these throughout June and July. Please tell your friends and encourage them to come along too. Thanks very much. Bye-bye.